Hello, I'm Joseph Nunziata. I, along with my partner Aditya Sood, will be presenting about NoSQL and its relation to a database company called Couchbase. Throughout the fall semester in CS623, we've been studying the foundations of relational databases, the logic behind their formation, their applications, and how to utilize SQL to manipulate data. However, the database story doesn't end there. There are many limitations to the relational database structure, and new developments in the space had to be made to accommodate for the massive amount of data that is produced and collected in today's modern society. This began the advent of a different type of database structure, one that would be able to work with and outside of the constraints of relational databases and the SQL query language. As previously discussed in class, relational databases have shown various inefficiencies. They do not produce results for modern-day large data files and files of different types. As data and their analysis became more complex, new solutions were created to reorganize and optimize the field. The main development was a paradigm shift away from solely operating within the constraints of the SQL query-based language and the relational system. This meant that some of the ACID transaction properties had to be broken to accommodate such new features. The new query language and concept was called NoSQL, which generally stood for Not Only SQL, and was used as a name for Carlos Drazi's open source database, which did not use SQL for executing queries. This system was created in 1998. NoSQL is non-relational, meaning that it is not based off of the traditional relational links between schema and tables. This allowed for the development of different data structures compared to the SQL database system. This meant more format flexibility in terms of the overall data structure. With NoSQL, one can easily add additional servers or nodes to increase storage capacity. This allows for a greater amount of data to be stored within a network of nodes and allows extremely fast communication between these nodes. There are different types of NoSQL structures, but we will be focusing on a particular one called key value store. Key value stores use an associative array, which is also known as a dictionary or map. This model represents data as a collection of key value pairs, which are a set of linked items, a key and the value. The particular key value store based DBMS we will focus on is Couchbase. Couchbase is an open source JSON NoSQL cloud database system. Couchbase is the result of a 2011 merger between Couch1, a company that created the CouchDB database, and Membase, which was a NoSQL document-oriented database. Its creator is Damian Katz. JSON stands for JavaScript Object Notation, and through JSON, data can adapt to agile workflows and requirement changes. Couchbase uses a multi-node structure, which allows a user to consolidate multiple data structures into one database. Data is stored in clusters called buckets. It even accommodates SQL-based queries. It's an incredibly fast system that can process a multitude amount of data of various types within microseconds. I will now hand it off to my partner Aditya to speak about the Couchbase's various features and their importance.
Thank you, Joseph, for that really insightful introduction into Couchbase. I would like to further discuss about the features that Couchbase servers provide us with. So, as we know, Couchbase server is a NoSQL document database for interactive web applications, and it was the result of a merger of two popular NoSQL technologies, which were Membase and CouchDB. So, since the Couchbase server is a document database for interactive web applications. It utilizes a managed cache for sub-millisecond data operations, which means that we can gather our data really fast speeds in the matter of a few milliseconds. And it is a high performing query engine, which can use SQL statements, which makes it attractive to a large array of users. And unlike many other querying languages, it allows for ACID transactions and it also has a full text search and analytics tool, which is helpful when we have large documents and we are searching for some particular text, or we want to gather some information from the text that is present in a very large document. And there are also some other features that are provided to us by the Couchbase server, such as the Couchbase server has a flexible data model. Since the JSON documents are used to represent application objects and the relationships between these objects, this document model is flexible enough so that you can change application objects without having to migrate the database schema or plan for significant application downtime. The Couchbase server also provides easy scalability, since both within a cluster of server and between clusters at different data centers. And we can also add additional instances of Couchbase server to address additional users and growth in application data without any interruptions or changes in application code. Couchbase servers also provide easy developer integration, since they provide the clients with libraries for different programming languages such as Java, .NET, PHP, Ruby, C, Python, and Node.js. For read operations, Couchbase provides a key-based lookup mechanism where the client is expected to provide the key, and only the server hosting the data will be contacted. And for write operations, Couchbase provides a key-based update mechanism where the client sends an updated document with the key, and when handling a write request, the server will respond to client's write request as soon as the data is stored in RAM on the active server, which offers the lowest latency for write requests. As we know, we are living in a world where technologies are continuously evolving and speed is of the essence. This is where Couchbase comes in and has found its importance in a variety of industries. Customers from all industries are turning to Couchbase for an application data platform capable of transforming their businesses and providing exceptional user experiences while lowering their cloud operation costs all at once. These companies often share common motivations. Their existing applications are suffering from performance issues that are not easily resolved due to the rigid structure of relational schemas, or their teams have no patience for learning a new query language when SQL just makes sense. And since Couchbase servers can work with SQL, it seems as an easier option for them to continue working with SQL and use Couchbase servers, and their application needs to evolve more quickly to address the changing behavior of users. And since Couchbase servers provide a flexible database, all these changes can be easily made. So some of the main use cases where Couchbase is used in industries are to provide a 360 view of a customer, where aggregate data is collected from different sources in one platform to build a single view of the customer or business. And Couchbase server is also used for cataloging and inventory, wherein new when while publishing new products and inventory content in real time, and scale to millions of products and requests per second to present the right data at the right time.
One application of Couchbase's system is its scalability. One interesting thing that most wouldn't know is that LinkedIn uses Couchbase Server for their needs. Originally, LinkedIn used Oracle's database system, but they had a lot of problems such as backend system crashing. This occurred because Oracle couldn't scale read commands effectively. LinkedIn needed a system that was reliable and highly scalable to support their growing network, so they turned to Couchbase. Their main utility of Couchbase's cloud system was their caching system. Because they were able to cluster data across multiple servers, files could be read and changes could be made extremely fast. Their transaction processing speed established an average of less than 4 millisecond latency for 2.5 billion objects. Because of this high processing speed, built-in replication functions were developed, and the company could commence cluster expansion rapidly. This ultimately reduced operating costs and continues to support LinkedIn's growing user base.
Thank you, Joseph, for letting us know how Couchbase helped LinkedIn overcome their limitations. I would now like to discuss how Couchbase also helped Cisco overcome the limitations that they were facing. So cable companies worldwide use Cisco's VSRM, which is the Videoscape Session Resource Manager. It's an application to enable their broadcast, on-demand, and DVR video services for over 100 billion user sessions per year. When VSRM became overly complex to scale, Cisco decided to move the platform to a NoSQL database in the cloud. And after assessing numerous databases, including Cassandra and MongoDB, Cisco chose Couchbase as it was the best suited to overcome their challenges. Some of the challenges that Cisco was facing was that Cisco had to create a highly scalable media platform in the cloud to support over 100 billion user sessions per year. Cisco chose Couchbase over Cassandra and MongoDB since it had the highest data consistency, and this would help them overcome the challenge of accommodating over 100 billion user sessions. Since Couchbase can allow them to has a, as we already know, it has a flexible data structure and reliable, uh, and it is also very reliable and secure. All of these components and all of these features and components helped Cisco to decide that Couchbase was the best suited for to overcome all the challenges that they were facing.
Aditya and I were able to download a trial version of Couchbase's database system and test out 3 example queries from Couchbase's tutorial. The tutorial included a sample bucket or data cluster for use. It involved travel bookings for hotels and their ratings and reviews, destinations, and flight dates and times. Aditya and I coded each of the 3 example queries to test the system. Each time it outputted the correct results. The first example finds the top 3 overall rated hotels from the bucket. This example details data aggregation by using correlated subquery expressions in projection. The average overall rating if the given hotel is found by the subquery in the projection. It uses a limit of 3 to filter the top 3. The second example finds the top 3 hotels with ratings greater than or equal to 4 and with 6 or more reviews. This shows a nested path that is used to correlate the subquery expression in the let clause.
Thank you, Joseph, for explaining the previous 2 examples. I will now be taking up the explanation for the third example, wherein we did inserting data via non-correlated subquery with insert. So as so as you can see in the above example, we have a non-correlated subquery for and subqueries which are independent of their parent queries, which mean that they do not depend on any of the variables aliases defined in the outer query, nor the specific document being processed at the outer query. In such cases, the inner query has no correlation with its outer query, and that is why they're known as non-correlated subqueries. And for non-correlated queries, the subquery is evaluated once, and resulting values are substituted in the parent query for all of the documents at the outer query levels. And as we can see in the example above, we are searching for hotels that belong to the landmark hotels type. And we will be displaying distinct hotels in cities, and we are limiting the number of hotels that are displayed to 4. In conclusion, I would like to say that through the research that Joseph and I have conducted, we have found that since the world is becoming more information centric and there is more emphasis on the information being stored and used, we have found that the relational databases that were very popular during the decade that has gone by are slowly fading out as they have very rigid structures and companies that are still utilizing them are finding it difficult to expand their databases and also to meet their growing user demands. We have found out we have found that Couchbase, with its new innovations and the various features that it is providing, is a perfect fit for the changes that are occurring in the world. And through the developments of out-of-the-box thinking and navigating the complexities around databases and relational structures, new progress has been made in how data is organized, manipulated, and viewed. The increasing knowledge of these two technologies through Couchbase is allowing is, uh, is allowing for a modern way of living to exist. And this is not only helping the companies grow their user bases, but it is also setting the path for future databases so that they can improve on improve on the foundation that Couchbase has already laid.